So, Nikhil, first of all, I want to know about the company Tabor Electronics and what exactly the company do.
So to start with, Tabor Electronics started where like 5 decades ago, more than that. This company is based out at Israel, and earlier it was more of a mechanical, and then they started a business with uh, Keithley for the OEM services. So as we know, Israel is a um, probably a hub of the electronics and warfare systems. They are pretty good. So this big company has started collaborating with Keithley. At that time, it was more of a frequency counter. So they have designed in 60s, 1960s, world's first automatic counter. And since then, they have started growing these relationships, providing OEM services. So they are the one who used to provide the hardware design, basically built to spec to different OEMs in the test and measurement industries. So you name it, and Tabor Electronics used to do the OEM for some, not all the products, but let's say one of the product which has been put into the spec. So they are building it for others, and they have started the first product of Tabor's system basically in 2003, and in lately 2017, 18 around, they just wanted to focus on to Tabor system branded. So the OEM business has become very limited, and now we are just focusing on to the Tabor systems, Tabor electronic systems, basically the products. So we are in the test and measurement field, and we have been around more than 5 decades. It's just now we have started, the presence into worldwide.
And who are your target audience?
Basically, our major customer segment is aerospace and defense.
Mhm.
Currently, we are equally sharing into the quantum technologies as well. So we are building the quantum control electronics, of course. So the research institutes as well as startups who are working into the quantum technology field, they are our major segment, you can say, are the customers.
So, I want to know that for approaching your target customer, like how do you approach them?
So I have an experience of, probably around more than 15 years now.
Mhm.
So I have been into the different test and measurement industries. Previously, I was associated with Agilent's distributor. That's where I started my career. And then I was with Tektronix for almost more than 9 years. So uh, I have had few contacts in, across the India. So it's now to answer it, like we reach out to each and every organization with Connect, and we have our I have made the whole channel network as well,
Mhm.
distributor network who helps us to reach to India-wide customers.
So, Nikhil, with Tabor Electronics, you are doing from design to manufacturing everything in test and measurement.
Yes, yeah, very well, yes.
Okay. And I want to know that what are your top priorities when selecting a T&M equipment partner?
Okay, so top priority, like we are one of, I would say we are one of the test and measurement industry, and I have worked across, as I said, like different platforms
Mhm.
on the test and measurement. There are few products where customer is already, everyone is having their own biases, but I would say that the one very much product which is arbitrary waveform transceivers. Uh, this is a very niche product which Tabor is only currently having. No one else is having. So I would say for that list, I would put a priority Tabor compared to others, whether it be the Keysight, or whether it be Rodent Source, or it can be Tektronix.
Mhm.
So that way, I will put the segment wise priority.
Mhm.
We play in a very specific areas where our strength lies, like other other our product, if you see, we majorly have two categories. As we know, we are a signal source company. So
Mm-hmm.
anything which is, building us complex from CW to the complex waveform, we have a expertise. We know how to miniaturize the platform. So that's where our expertise are. And making it multi-channel, phase coherent, phase stable channels. That's where our expertise lies. So if I will talk about multi-channel signal generators, so again, I will have a priority because we have been building, so we know in and out how to, quickly do the phase synchronization.
Nikhil, where is your manufacturing facility?
So currently what we do, I would say, like, I will describe a little bit about India, of what we do here. So when I joined them, I have joined Tabor Electronics in lately 2021,
Mm-hmm.
keeping in mind saying we want to grow in India. Okay. And that time, like, I was the only one who has started. I used to do uh, the development aspects, application layer development. So that's what our products are different. So not like a typical test and measurement in companies. So we do application layer development. That's where we started, and then to make a complying, make in India vision, we have opened the development center. So what we do in our development center, which is specifically to an India site, is this is second largest, you can say, the research, or rather, like, this second only the company's research and development environment where we are doing this in India after Israel. Israel still holds everything in terms of a hardware. What we do here is the rest of bring up. For example, if there is a board, from board, we will be trying to build up the core FPGAs, some of functionalities on the FPGAs that will be built up into the APIs, and then to the parsers, to the front end, and then to the applications. So this whole full stack development part, which we do it here. Other than that, what we do is we do a calibration, and calibration is not just post purchase, the instrument calibration. This is calibration which is any hardware releases happens. So before that, we need to tune the hardware. So we call as a optimization of the hardware. So, or a system validation. So that particular part we do it in India. And then finally, product packaging and assembly. So this is typical services which we do it in India. Currently, this all happens in at Ahmedabad location.
Okay, so your
Yeah,
development center is in Ahmedabad.
Ahmedabad. Yeah, right.
Okay. And in Delhi?
Delhi, we don't have. We do have a presence of like a local channel network, which helps us, as I said, in reaching out customers.
Mm-hmm.
But we have a home office in Bangalore.
Mm-hmm.
Yeah, that's the another place where we are currently looking out to offshore some of their activities.
Mm-hmm. And any other plans you are like any other future planning you are planning to make new development center in India or any other manufacturing facility apart from
Um,
Israel?
yes, yes, definitely. So, as you know, we are our major another focus, as I said, like, is a quantum technology,
Mm-hmm.
and we are also focusing a lot on that, and we are a part of a lot of national quantum missions, technological groups, where we are hoping to have some more outsourcing or co-development activities which are going to happen, but that yet to happen, since it is very at the initial stage and yet to get developed everything on the quantum front. So we are hoping to have it, those new developmental areas. Other than that, we are also now trying to implement a lot of you can say machine learning and artificial intelligence applications embedded in our hardware, or our instruments, as to make it a final product related to the EW or ECM applications in that, or drone detection. So these are some of other RF systems part which we are focusing on currently, other than quantum technologies. Yeah, where new
O-
development will happen certainly. Yeah.
Okay, Nikhil. So you said that you're focusing on quantum technology. So what are you actually doing, like building quantum computers and all? What
Okay.
you're actually focusing?
Yeah. So we already have built one quantum computer.
Mm-hmm.
This is a 5 qubit quantum computer, but not in India. What we have done it is in US. This was the partnership between, it's because quantum as quantum computer, if you'll see, there are four main part of it, right? The quantum control electronics, then you will have the RF accessories under the dilution refrigerator, and then you will have the quantum chip, right? So each segments are having their own expertise. One cannot have, the expert of a
Mm-hmm.
quantum computer say, I can myself can build a quantum computer, right? So this was a partnership between three of us. We got a chip from a company called Quantware, and dilution refrigerator from the Form Factor company. Form Factor is typically a new name, but people used to know them as from Genis cryogenic systems, which currently utilized by Google actually. Right. So, and rest of other things from us to build the pulse sequences, to build the measurements and integrating the services. So we have already built a 5 qubit, as I said, like quantum computer, which is having, if I talk about the specs, it's very much decoherence time typically we talk about, which is in high order. This is before applying any kind of machine learning and
Mm-hmm.
you can say calibrating it. Right, this is a raw performance which we have measured, and we have published also into the uh, American Physical Society APS as well, that those papers are there. The other part is we are working towards, so quantum technologies are having four pillars: quantum computing, quantum sensing, quantum materials and devices, and the fourth one is quantum communication. So major our focus is on three technologies: quantum materials and devices, quantum sensing. The second part comes as a quantum sensing. So quantum sensing also there are control electronics uh, which we have already installed also currently in India. There are few installations which are there, and quantum material part is also there, where we have built up a specific, you can say, the test setups for that. So our expertise lies is in majorly integrating, the quantum hardware and building the quantum control electronics. There are a few computing aspects. There are different technologies which has, really developed in India, and our team has also flown to Israel to integrate and test those developed, you can say, stacks.
Okay, so when you talk about quantum material, I mean, what do you mean by quantum material? Can you give any
Uh,
example?
Actually, this is a buzzword. The moment
Mm-hmm.
the quantum technology has started, the material was already
Mm-hmm.
exist, but now we are, making a segment very niche material research in such a way that we are trying to find out the materials which are good in terms of which can exhibit and demonstrate the quantum mechanics better. For example, let's say uh, we are trying to explore a new material called niobium titanium nitride, which is a very good material for cryogenic applications, which is essentially will be used into quantum chips as well as the cryogenic amplifiers as well as into the single photon detectors, which works onto the cryogenic temperature on quantum communication aspects. So currently we are engaging with few institutes, say AMPRI, which is in Bhopal, CMET, which is in Pune, to
Mm-hmm.
and ICER in Mohali. So these are some of joint projects which we have already written with it. We
Okay,
have a
okay.
MOU in place with IIT Gandhinagar as well as IIT PHU. and ISA Bhopal for these all quantum related activities.
Okay, so what methods you are commonly using to grow these high quality quantum material?
Currently, there are no methodology which are
Mm-hmm.
there. What we do is the material which are already been, shown the good characteristics in terms of like, let's say, superconducting, methodology, or where we are trying to see that okay, quantum mechanics works better. We try to take that material and build some of the devices out of it, or we do a simulation on those device material, putting the in different forms. Say for example, we create resonating cavities and try to see the resonance of it. And the other is there is a specific device called traveling wave parametric amplifiers, TWPA. So we try to put down to the device level and see that how materials are exhibiting a good quality in terms of lowering the noise at RF levels, as well as giving us a good output.
Okay. Okay, and also how can the quantum devices be used in real world fields? Matlab, can you give
Okay.
any examples?
For examples, there are many ways currently, but currently we do not have effective number of logical qubits, which is they are good enough because they like superconducting qubits. If you'll see, they are error prone. Right. The other technology which we are working is on a trapped ion method, where we have already 40 qubit quantum computer has been given to one of the startup in Israel named Quantum Art. So the logical qubits are very less. So effective computations, which we are trying to do, is in like replacing the um, uh, supercomputers, right? Is right now is very early stage. But for example, space side, let's say the launch vehicles, how we can optimize the routes, right? How we can get the better, say the signal to noise ratio, or which are the different conditions of the weather, which will help us to effectively navigate, right? Or optimizing the fuel perspective. The other part is, let's say, talk about the electrical vehicle, right? What are the different materials which can exhibit into the EV batteries effectively, which will be eventually a substitute of lithium batteries, right? So these are some of the
Mhm.
very uh, result-oriented computations which are required, right? That's where the currently quantum computers will be really helpful.
Okay, so where do you see the most impactful use case of these devices in in upcoming next 5 years or 10 years?
I would say wherever there is an intense mathematical and permutation combinations, which are there, those all places in next 5 years, quantum computer will be easily able to replace it. Just don't one place from my point of view is we people are making a quantum computer to break the securities, right? In terms of AES codes, but that is like very far yet. uh, so other than like a cryptographic break, we will be able to see in next 5 years many places quantum computer will be utilized. It can be a banking sector, it can be a trading also, share market, right? The financial fintech companies. So these all places will be a good, where the quantum computers will be effectively used. The other place is the QML, which is quantum machine learning, which when will be integrated really. So that will have a lot of other impacts on the daily computing.
So, Nikhil, how do you evaluate the ROI of your current test equipment investments?
Okay, so typically, I would say being good Jew, we think always onto the ROIs. Uh, I would say that um, I will take rather as an example. So say for example, right now, quantum computer for 5 qubit, right, which is costing us, let's say, some somewhere around $1.2 million, right? $1 or $1.2 million. Now, how, let's say 5 to 10, when we are going to go, what are the cost advantages which we're going to get? Should not be a double, right? Of course. So that's where the major part involvement which is come, right? So ROI in terms of like currently what we are seeing is in terms of installments, where the major reducing down the cost of the testing instruments or the test devices will be very effectively, right? We have built a common architecture in terms of, let's say, manufacturing. Now, you see, we have a aerospace and defense, we will have a quantum technology, we have a wireless communications, we will have a semiconductor also, test systems, right? So this across the platform, if I will keep designing the new product, so I will have to have a many places, different workforces as well as different experts who will be in it. Right, and that's the biggest, you can say, in terms of investment before we get the product out. Rather, like what we did is designed a one very common architecture which meets, let's say, major requirement, 80% of the requirement. And then you try tuning each and every layers with respect to different applications, be it uh, aerospace and defense or quantum technology or wireless communications. The other part is we are also believe in integrating the solutions. So for example, uh, MathWorks is already very rich, right, in terms of different tool sets. So we try to find out a way how easily we can integrate this MATLAB into our environment and make it user friendly, so that many of the organizations who are already having license, they don't need to purchase the new, and then they can seamlessly try integrating this. And on other side to us, we no need to invest too much onto the specific applications, and then try to reach out to market where there are already a lot of people around trying to fight it out. So I would say an open source architecture, which really helps us in terms of building our ROIs very easily, which helps us into the manufacturing, basically, hardware platform.
So I want to know that for that Tabor Electronics, how it maintains authenticity and accuracy of its products.
So this is a good question. So since I would say I would start from there, we have been building signal sources for past 4 decades, as I said. A lot of our work happens on the FPGA. All right. And now to talking about the accuracies, of course, we use standard test and measurement instruments to uh, make a measurements, and then only we try to publish it. So we do have the standard golden reference, you can say, the spec sheet or the measurement where we want to achieve it. So that is one part. Now talking about authenticity, we've already tried with multiple different platforms, which we do it in India, in fact. For examples, I would say that our solutions are modular, which is in PXI based also. So PXI based solutions does not only fit with our the chassis, and we do a measurement and we publish it, but we have a cross platform also. Say for example, we try with AD-Link chassis, we try with the NI chassis, PXI, and then we try to measure the same thing, and then we say that, okay, yes, these results are there. So cross-platform compatibility also we test, which authenticate us, saying that this platform is seamlessly giving consistent and repetitive measurements or results.
Okay. And Nikhil, what process do you follow to ensure high precision and reliability in your equipment design?
Okay, so probably I may not be the best person to answer this, but I would say our team in Israel is really good. They are really technocrats about building up RF systems as well as digital systems rather on the FPGA, having almost around like the average experience over Israel team is about 20 years. So many people who has you know when the company has started, since then they are there. When actually we started building the sources basically. So I would say the experience which hits us, the more and faster, which helps us to define the design and hardware quality.
As you said that you are using FPGAs for your signal source design. So how do you decide between using an FPGA or a microcontroller or a DSP chip for a signal source application? Why you are specifically using FPGAs?
Okay, so the reason to use the FPGA is these are, if you'll see our hardware, these are all commercially available hardware, right? So that means we are building we are building one which is already available, which gives us the one of the price advantage, right? That means we are not too much spending on our specific chipsets. If we talk about FPGA versus ASICs, ASIC requires like a lot of long R&D, innovations as well as time. And we are just started in, expanding, you can say, outside of Israel or doing our own business. So we are very at early stage to, have a vision to have a ASIC specifically for our applications. So rather, at an early stage success, we are trying to use what are available and then making it work, which is even better than specifically to ASIC. What it limits is, yes, it's technology. So say currently, which will be only available, whatever it is in commercially available platforms, say from either, let's say the chipsets which we are using is TI and currently TI and say analog devices which are there. So we will be limited to that DAC and ADCs. For FPGA, we use Xilinx. So they are resourceful enough to make it work. So we are just putting across them together, and RF board design is one of our key expertise. We discussed this topic along with one of ISC professor as well.
And what tools do you use for debugging FPGAs, signal processing design?
It's a Xilinx ID, so we use Vivado also, and then
that you use for simulate and design for synthesis, right?
Right. We don't do any intense high, FPGA simulations and processing. Otherwise, like there's a tool from LDEC which are also pretty much good, which few of customers are using. I know them when I was proposing our hardware at that time. So LDEC tools are also good for FPGA simulations.
So, Nikhil, I want to know that how do you differentiate your products in a competitive T&M market dominated by major players?
So I would say, whatever the solutions or the product which we have sold so far, everyone is having their own case studies rather than just a product sale. Product sale still, like I'm trying to fight with the bigger players 1:1 in terms of commercial aspects. Big giants who are there, they already they have a multiple product basket, so they can and they have a deeper pockets also, so they can work at very low margin too. But majorly my way of selling or selling products is providing the solution in terms of whatever the current challenges are there, and we do development also in terms of keeping those in mind. For example, currently altimeter testing solutions. So altimeter testing solution, there are few Aeroflex products which are totally comes under ITAR. So we have locally developed those solutions here and we have provided. So that's where, I would say there is no one comes into the competition, and we will be also rewarded with what, R&D efforts we are putting it in. So that's a way, I see the market and I pursue it.
So, can you describe your strategy for handling obsolescence of test equipment in long life cycle industries?
Currently, if you'll see, I still see many requests, the older, probably 2000, before early 2000 supplied equipment. So those are all like, some of them are working fine and some of them are now component has been oscillate, right? So what we do is we try to make it code compatible, but we try to make the life of any instruments around like 15 years at least. And if you see, still in early days, Tabor was only company who used to give a standard warranty of 5 years.
Mhm.
So that's, you can say a level of confidence into the design as well as, on the product which is there. So we still, if you see our few products comes with a standard 5 years warranty and standard 3 years warranty,
Mhm.
uh, uh, rather having any extra, the options associated with it.
Okay. So, and what about the engineering challenges? Like, what are the biggest engineering challenges in developing high frequency or high voltage devices?
Yeah, currently, we are currently in the development of 40 gigahertz unit. So the major challenges for us, which was there, was RF port design and hardware integration. That's where we are currently facing a lot of challenges. As we were never having any experience of going beyond RF frequencies or microwave frequencies rather, millimeter wave frequencies. So that's where we are seeing a little challenge in terms of having an experience in building it. So we are trying to figure it out, and we are bringing some consultant who are expert in design at around like 40 gigahertz of frequency range, to make it very smooth. But major challenges, as like India team does not handle, the pure 40 gigahertz generation, but currently we are trying to work on some of designs which do up and down conversions as well.
So, Nikhil, how do you ensure compliance with global testing and calibration standards?
So we have our own lab and we follow the standard methodology which is provided by um, say Tabor Electronics and their Israel standard lab. Just like we have a NAPL, they have their own lab over there. So we follow the guidelines which is provided by them. In India, currently, I do not have, or Tabor doesn't have any NAPL accredited lab. So what we have done is we have partnered with a Bangalore-based company to provide the NAPL accredited calibration for them. If locally traceable calibration done, then we have our own instrument setups which can be traceable too, with the standard instruments. Yes.
What percentage of your R&D is focused on innovation versus improving existing technologies?
Okay, so our major focus in India team is, almost 60% you can say is focusing on to the new development rather like older development. As I said, like platform is already been fixed. Now what we work is on to the tuning that platform in different applications. So we are new. So, we are trying to open every other market which is possible. For example, a couple of years back, or not couple of, like probably 2 decades back, we designed a special unit which fits into the semiconductor manufacturing. So our part was supplied to Applied Materials into their test systems, and they used to do the etching part, the complete wafer. Right. It's a very similar way. We were the first one who whose control electronics was used in IBM's quantum computer. You may have seen like Time magazine's IBM quantum computer along with Sri Arvind Krishnanji, who was standing there, right? So behind that, whatever the control electronics was there was from Tabor. So, being a part of the system, like which will eventually help it.
So, Nikhil, do you provide any customer support or training also?
We do provide, yes, definitely. We have been providing to all our customers about say different of course, other than what the standard test and measurement of the self which is required, but we do provide some sort of training on handling and designing, not hardware designing, but designing the systems as well. Yes.
Okay, so how are you adapting your business model to trends like remote testing, predictive maintenance, or digital twins?
We still do not play anything in digital twins area. Remote testing is, yes, one of our focus, for which, many of the things we are developing it here in terms of building the servers, which can directly get accessed, as well as going rightly into the remote connections and desktops of our products, basically. So those things are, which already has been taken care into the account, and it's been taken care. We yet to go on to the cloud side. That is, very far future for us currently, which I'm not seeing in any near than another 2 or 3 years, until like we put across some of as I said, like quantum mission. If we get to offload some of the developmental activities, we would love to do that, but until then, like, there are no plans to go into the cloud side.
Okay, so you talked about that you're working on 14 gigahertz frequency. So what are the challenges that arise, when designing a circuit to operate at
Right.
such frequencies?
Um, the major challenge was the hardware integration. As we have the synthesizer source, and then we put across the hardware together. And when we simulated this hardware, it was working just fine. But when the hardware side, we have started integrating on the breadboard or the prototype, we started seeing challenges in terms of a frequency locking and enough fast switching, which essentially is required. And the third is the calibration. Calibration, as in, like, I would say, the file which is essentially will be put onto the device. So these are some of the major challenging areas which we have found. The fourth most challenging area is, let's say, for 20 gigahertz, which is the product is already out, and we have an installation of that also now. But say, for example, the prototype is working fine as per the specifications of datasheet. But when the hardware RF board which has come up, that have started playing, the emissions and locking again, some of the spurious which will start seeing it. So this is where, the RF Pro from prototype to RF board is giving a lot of challenge. So there are multiple versions of it, which we are keep defining it. Now, however, based on different, say, for example, the amplitude drop, which supposed to be maintained 0 dBm, but we slightly seeing it, let's say 3 dB down, then why it is happening, then we try to put the uh, the resistors to ensure the feedback loop, to ensure the ALCs are already there in it, in the signal generators, right? So we try to put this again into the simulation and see that the boost has happened, which compensate this or not. And again, we put back into the FPGA to compensate that.
Okay. Okay. And also, what are some of the common sources of signal degradation at this frequency and how you minimize them?
I would say the major cause is the RF board and clock
Mhm.
leakages. So we use a very high speed clock to, let's say, synchronize multiple synthesizers to make it phase coherent, and feedback system. So these are major cause, which needs to be taken care while designing it. The idea is like, when we start seeing, let's say, the signal quality, we start saying the phase noise. So for the, let's say, the phase noise, we have selected one OCXO and then start seeing the performance with the multipliers and the frequency synthesizer input, the filters and RF system for the budget analysis, and then finally we degrade it, right? Now, replacing each and every component will help us to do a perfect budget of RF systems. So that's how we try to tune each and every, the parameter one after the other.
Okay. Is it challenging to synchronize FPGA clock with external signals?
Um, I would say, yes, it is challenging, but now we have already more than a decade of experience in building
Mhm.
phase synchronous and devices, so we know where to find out and what needs to be changed. The architecture, how it needs to be implemented. So as like our older generation signal multi-channel signal generators were up to 12 gigahertz. Now we are increasing it to 40 gigahertz same way. So we know the methodology. So time to market, or say, let's say, product designing phase will be reduced down in that case. The major challenge is like the feedback systems, right? Which you take the signals and, let's say, the FPGA and say, if you have a single board computers, which is taking time to process and give the feedback back. So this is the major time where you will be able to, start seeing data. And this is where we try to work on majorly on our FPGAs as well. For example, when the trigger signal comes in and then the signal goes out, right? So this is the minimum time which FPGA takes it. So how we can reduce down, how to write an effective Verilog RTL
Mhm.
level logic,
Mhm.
as a feedback system. Yeah. So these
Mhm.
are some things which needs to be taken care, and that's what we do as a standard practice.
Okay, and also you said that you are using ML and AI in hardware. So, what are their role?
Okay, we are going to use, we are trying to integrate now some of signal spectrum behaviors. Say, for
Mhm.
example, first, very basic is like, I just want to try to find out between the signal difference between whether it is a wireless LAN or whether the signal is actually coming from, some other third signal, which is like, let's say, drone signals. So we are trying to work on these solutions and trying to integrate in our hardware, basically.
Okay, and also Tabor has evolved from OEM manufacturing to a global brand. So, what are the challenges that you have, faced in developing for OEM versus the branded products?
Yeah, I would say the mindset, when you are a company who used to, just take care of the product supply, right? Your mindset trains like that. The
Mhm.
major shift and major challenge, when I joined them, was the customer oriented mindset. And that's where I had to tune a lot into the company, saying, we have to be a customer centric, not the product centric now. Because earlier, the job of an OEM was just like, my hardware is ready, you take it, now it's your, headache to do it now.
Mhm.
But when you are selling a system, now everything is your headache, right? So we have to be more focused onto the every other support activities which are there, right? So first, We have built those all infrastructure in 2 years time frame, and so now as an ecosystem it is ready. So for me, I would say to convince the management is about like going from the product centric to the customer centric.
Also, since you make signal sources, so when adding a signal source to a big test setup, like for example with Fluke, so what synchronization or connection issues come up?
Typically, there are no typical, the challenges because unlike the other test and measurement instrument, these are also having clock in and clock outs, as well as 10 megahertz reference or 100 megahertz reference in and out to synchronize with other instruments. The challenges comes when, uh, yeah, say for example, our instrument can also accept a very high speed clocks to make it the synchronization very less in time compared to, let's say, 10 megahertz or 100 megahertz. The faster can be 3 gigahertz or 3.3 gigahertz signals, right? So when we are trying to synchronize at this high speed, the major challenges comes. For example, one of challenge which earlier when we were detecting was, although that was internal to us, but I would like to sell uh, the cables which were has been used to prescribe the correct power levels and the frequency range was not well tested. So the bus bar connector was having very low uh, frequency range, and high frequency range it will deteriorate. So this often gives us troubling in integrating at a higher clock side, uh, the drop of an amplitude, and now the receiver is typically requires some power level,
Mm.
and it was not able to see, so it was just losing out the connections every time. So probably I would say the third party things, which are coming in, they are major challenges. Now we also
Mhm.
understood. So every time, like we see first, we measure ourselves first, and then we only, integrate it.
Okay. Okay, and also, what are the most exciting signal source technologies your team is currently working on?
I would say currently we are working on going beyond 40 qubit system. So that's the major one which we are working. Currently, our modular platform, right? PXI Gen 4 chassis. So this can hold. These are having 21 slots, and these are all like PXI hybrid slots. Um, and it can host almost around like 10 modules of ours. So it makes it like a 40 transmitter channels, be it quantum, be it beam forming or beam steering applications. This can be used very well. Now, if we want to go beyond this 40, so currently we are working on a synchronization method which helps to integrate this both two different, the PXI chassis seamlessly with approximately less than 300 picoseconds of delay. So that's what we are targeting right now and working on uh, for, as I said, like it can be a beam forming or it can be a quantum, which this will be used for both the applications.
Mhm. Okay, so what tips do you have for EM design engineers, who want to build top test gears, and what you look into given you're, hiring new talent, then what you are looking at?
Typically, I always emphasize too much onto the fundamentals and basics principles. So um, I always see this in terms of the talent. So one, for example, let's say whether it is a EM engineer or RF engineer, if the basics are clear, he will be easily able to know the root cause and where to find the root cause. So that will be a key, the problem for everything to solve it. And one know how to reach there is basically what we are currently looking at also. Say for examples, the typical, the ground plane and the quarter wavelength, why we use a quarter wavelength, why not, you know, let's say lambda by 8, for example. So these all concepts which really helps them. The other part is the typical each and every, the wavelength, uh, as well as the frequency response uh, for the tracks are also very important when we go into the high frequency, because the smaller track can also be radiated. So these are some of the fundamental things which we look at out in terms of designing. Although we do not do too much, like we don't do the design, RF board design here, but the system level, what we do is application layers as well in RF. So what typically I start is like very with simple like questions of the communications.
Mm.
Why we do use communication, what are advantages, why we want really first the modulations and stuff like that, right? So if the person is clear in the basics, then he will be easily able to scale it up, because we know how to tune them into the our path one after the other. So I always emphasize on this.
Okay. Okay. So basics of communication system and signal processing, right?
Yes, exactly. The signal processing. See, if a person do not, if person is telling like I know AI ML, but if he
Mm-hmm.
doesn't understand what is transformers, that's like useless.
Mm-hmm. Right.
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 Yeah. So and
Okay. And
same
mhm.
way for the signal processing, if it doesn't understand how the floating system works and
Mhm.
how the floating numbers can be converted in different ways to manipulate further in the DSPs, so it's no of use.
And is there any requirement of learning a programming language like Verilog or VHDL? How
Yes,
important is
definitely.
that?
Yeah, it is very important, because our major we all focus is on FPGA, and that's where our expertise lies in. As I
Mm-hmm.
said, like because we have only one FPGA which can be shared between DAC and ADCs and our transceivers, right? So the resource utilization has to be minimum, so that the more logic you can put across into the FPGA. So we
Mm-hmm.
always try to, bring down onto the problem statement of how you can make your code very effective, be at
Mm-hmm.
RTL level or be at, C++ or Python, whatever, like
Okay.
across this. We try to see like how with the minimum resource of the memory, you will be able to solve the problem. And that's always our key, you can say question to judge any, or, as you can say hiring. But
Okay, okay. One more question out of curiosity. So, if
yeah.
a person knows C or C++, you will assume that he will do well in Verilog and VHDL also, because these are completely different languages we see.
Yes, I would say again, uh,
Mm-hmm.
these are just the model languages, right?
Mm-hmm.
The key idea is to logic, right? For mathematics, there are for one solution, there are 50 different ways to solve it, right?
Exactly.
But which one is the most effective? And that's what we need to get it out from them. We try to give hint. If he reaches out, then
Mm-hmm.
probably, he just need a little more direction in finding out the solutions and tuning in that directions. So we just try to see the small, these behaviors while hiring the
Mm-hmm.
candidates.
Okay, okay, that's great. Okay, Nitisha, you can ask.
Okay, so how do you manage cross-functional collaboration between R&D, production, and marketing teams?
Okay, so I would say we are a very small company. So here we do a lot. People are doing very multiplexing jobs, all
Hmm.
right? So as in like I handle the collaborations between the product team as well as uh, the local R&D here as well as R&D in the Israel, where the main product team also sits. So we always do this. Being a small team gives us advantage to quickly take decisions, as well as people are quickly available. Uh, so uh, I would say this is the advantage of being small, where we do not have to follow too many processes and can really engage, between teams, engagement between teams.
Are you planning to increase your team? Like, is there any future plans for new facility, new development center, or any other future plans which would you like to share with us?
Yes, we are planning out some of other things which we are looking at is the outsourcing of our work also. So in that direction, yes, we are working out. But we need some more expertise, which currently we are trying to figure it out, like how we can bring them into the team and can work as in collaborative way. As in, like, as I said, like 40 gigahertz up and down converters, which we are trying to integrate. So we are seeking for some partners who has the experience and he can, quickly tune it for us also. So currently we are exploring those, across like India as well as outside of India as well, both the places.
So is there any specific criteria or something like that, or like how do you searching for those kind of partnership?
We majorly see their work and the projects which has been delivered and expertise into the team. These are major, and yes, of course. However, different depend on different companies. They have a different project, so we try to tune in that direction. But overall, what the first criteria to say yes, we can talk and we can initiate the talk is the team members, and what are the expertise and what are the projects which has been delivered in, and it should fall in, like, our basically the requirement area.
Okay, and what are your marketing strategies to grow your company more?
Okay, so currently, as I said, like we are focusing more onto the quantum, as quantum is becoming, now a mission. So we are working towards this. The second is Make in India, which we wanted to loud out, saying now more than 70% of the product development happens in here, including assemblies and test. We are also recognized by state government of Gujarat, for manufacturing this. And currently we are under registration to the STPI as well, for exporting our services or the work which are there. So my key two things is one, the priority wise, like yes, Make in India, and we wanted to reach out to every other single defense manufacturers or the integrators to give us a chance and see our technical abilities to integrate our products. Uh, the second one is the quantum. We want to rely on the National Quantum Mission, of course, and how we can progress towards that in terms of developmental areas. Yeah. So these are major two aspects on which currently I'm focusing on.
And how was the last fiscal growth? And what will be your plan for upcoming 2 years?
The last year was not that great for us because of the election. So we are very limited in numbers. So my last year priority was to fix the R&D, as we were just growing in that. So the R&D part of the product part of it is be fixed. And this year we wanted to get the numbers. I don't know right now what I would say, but we are growing at more than 100% of scale, basically. If you see the FY21 to FY22, it was 400% because that is, of course, because the Tabor was not doing business, and then all of a sudden we have started, getting the business in. So, but for next 2 years, we wanted to grow in terms of R&D team as well as in terms of sales, to double down what currently this year we have planning. So at a pace, currently we are 250%, on which rate we are growing if you average out.